Welcome to ClickMyProject.com. Now we discuss about the product for efficient resonant frequency modeling for dual band microstrip antennas by Gaussian process regression. Next we see the abstract for the product. The methodology based on the Gaussian process regression for accurately modeling for the rectangular frequencies of dual band microstrip antenna is presented. Two kinds of dual band antenna were considered, namely U-slot patch and a patch with a center square slot. Predictive results of high accuracy were achieved to the normalized root mean square error of below 0.6% of in all cases. Even though the square slot patch modeling problem where all the antenna dimension and the parameter were allowed to vary, the resulting in 7-dimensional input space. Training the data requires to achieve the accuracy were relatively modest. Furthermore, the automatic relevance determinations property of Gaussian process regression provided a mechanism for the recognizing the quality of understanding of the antenna. Resonance characteristics. Microstrip antenna forms to ubiquitous part of the contemporary microwave engineering, crucial for their designs in knowledge about the reasons of resonant frequency behavior. The process regressions of the resonant frequency of the particular dual band microstrip antenna is a function of the antenna design variable. Example, the geometry, dimension and substrate dielectric constant. Such models are useful to the fast acoustic of resonant frequency need for obtained for multiple different configuration of design variables. For example, an antenna engineer might need to be the dual frequency antenna to the function within the environment where surface area is limited and or where the choice of dielectric laminates is restricted. A model of sort present here would enable to the engineer to quickly investigate various combinations of design variables. Example, batch dimension, substrate height, dielectric constant. Selected to the adhere to the given constraints in order to identify the configuration that might best meet of resonant frequency requirements. Next we see the flow diagram for the antenna design. We implement the antenna design using the HFSS software. This software to implement the high frequency synthesis simulator based frequency development and the bandwidth calculation to be all the designs and developments to be included in the HFSS software. So first we open the new HFSS software and new project design in our 3D model based designs. Then create a new project design. Then go to first we create the any one of the antenna. First we choose the substrate model, and to analyze the substrate model and the dielectric constant value and permittivity value and the dielectric substrate modeling type, all the things to be noted. Then we select and create the patterns for and the shapes for our substrate model, because example for circular or rectangular or square or triangular based substrate model used in our any one of the HFSS modeling designs. Then we apply the which substrate model to be implemented. Example for Roger or Roger 54003 or 5005. So then to apply the substrate model, then we go to the assign substrate material type. The material is represents the same like a Roger material, and we go to the patch model design. Whatever patch model we use, the circular, square or rectangular patch model to be implemented in our designs, and we using the polyplane for rectangular shape cut all the things, and we add and subtract the implement design and to connect the what are the patch model implement in our secured diagonal patterns, and we implement the XYZ dimension based substrate model design in our secured selected new project. Then we go to the to design the bottom patch and top patch design. Every model consists of the ground plane and the top plane structure for our required patch wise designs. When the substrate to be included and the multiple substrate model and the 3-layer model and all the things to be designed in the first design based process. In every antenna design, we implement first the design phase completions process to be calculated. Then we go to the final design phase process. After design process to be completed, then we go to the analyze setup work for every antenna design. The analyze setup mainly focused by the boundary wise designs and the excitation wise designs in our field setup. Whenever you use the electrical field and we use the waveport model, and the magnetic field we use the step up port model for overall antenna designs. These designs to be applied for the frequency range. Then to set the frequency for a start and stop frequency and the solution frequency. The solution frequency to be changed based on the antenna model designs, and whatever we working the full bandwidth and to coverage with the center frequency range for our required solution frequency model. Then to set up all the frequency model and to run and the overall process. Then if the run to calculate the S parameter, and it's like return losses for our required antenna design, then we go to the empty boundary box to be set up for our required antenna model design, and to set the radiation pattern. This radiation pattern to set the pattern wise model for our required 360 and 180 degree pi and theta value for setup for our overall radiation pattern. Then to calculate the radiation pattern graph and the polar plot graph and the gain level and all the things VSWR, each and every analysis for required antenna design to be calculated for our required model, final model. These are the final flow diagram for the antenna design process. Finally, we see the output for the product. This is the project on HFSS file. Just public the HFSS model and to open the required antenna design. Then open the design model and to process with the new project deviations. These are the overall designs, and to this is the feeder point structure, this EPG structure, these are the required antenna model design. These are the final output antenna model design for our required final process. You just simulate, then synthesis our required antenna model. Then we go to the results file and to just see the antenna model design, and to working for our 3-band structure for required our final output for the structure. These are the 3-band structure on the band separation technique. These are the final design working with our correct output procedure for our antenna model design. Then we use the BEC material structures and the lumped port and the perfect E for our required EPG structure and the ground plane and the top patch design. These are the final output for our antenna based model.